All right. So this tells us the number of licensed vehicle drivers in a particular country, or county, excuse me, is shown in the table. Suppose a driver is selected at random. Find each probability. So the first one, male and over age 59. Okay, what am I going to probably need to do first? Add everything up. All right, you guys, this half add up the males. This half, you guys add up how many females we have. How many males did you get? Okay, what about females? So total, if we add those together, okay. So the driver is male and over age 59. When we have the actual data in the table, it's not as much following the formulas as it is just finding the ones that meet the description. I need male over age 59. So my males over 59 are those people. So if I add those up,
1,196.
that's over everybody. So we get 0.1119. Okay. B, the driver is female or under the age of 30. So females, how many females do we have? Or means add. How many do we have under the age of 30? So I could add up everybody, or could we say, I've already added up all these females, so who do I need to add in?
Just the men under 30.
Just the men under 30, is that okay?
Yeah.
And I get 0.62. So if you're reading from the table, just find the numbers that meet your description. C. So if I look at this one, the driver is female, given the driver is between the ages of 20 and 49. I already know something. I have someone between 20 and 49. So I am only looking at these people. I know it's one of those. So what should I do with those 6 numbers first? Add them up. And will that be the numerator or denominator? You're given, that's my total number that I can use, that goes on the bottom. Okay. Now, only looking at that group, how many are females? So I'm going to add up those 3.
2,636.
Thank you. And so if we divide, we get 0.4979. Do you guys see where we're getting these numbers? driver is between the ages of 20 and 49, given the driver is female. So I already know I have a female. So my denominator is the total number of females, 53, 54. Out of those females, I want everybody 20 to 49. So that's those three. That's my 2636. I get 0.4923. Any questions on this? Number 2. Suppose there are 3 traffic lights between your house and a friend's house. Each light may be red or green. List the sample space. What's a sample space?
All the possible.
Every possible combination. So I could have 3 red lights. Or I could have the first 2 red and the last one green. Or first red, middle green, last red. Or green, red, red. So that's every combination with 2 reds. What else would I have?
All these.
Mm-hmm. Okay.
Red, green, green.
I need all the combinations with 2 greens and 1 red. So red, green, red, green, red, green. Green, green, red. That's every combination I could get with my lights. So the probability for stopping for exactly 1 light. So you stop on a red. So I'm asking, how many of these have exactly 1 red?
And the way you find if you have enough things is you do the number of, like, red and green, there's 2 options times the number of options, like,
Yep, so there's 3 of them, so 2 times 2 times 2 tells me we should have 8. So how many of these have 1 red light? 3 out of the 8 total, which gives me 0.37. The probability you will have to stop for at least 1 red. So how many of these have at least 1 red light? 7. Everything except the all green one. So 7 out of 8 would be number 3. These are sometimes harder just because I don't have actual numbers or a sample space to look at. I have to use formulas here. So if A and B are independent events, what does it mean if I say something is independent? The probability of one happening is the same even if the other one happened. And that would work for both. So the probability of B is going to have to be the same as the probability of B if A already happened. The conditional and the regular probability are the same. That is the definition of independent. So if they're independent, one thing happening doesn't change the other. The probability of you wearing pink does not change the probability of you being in stats class right now. Okay, they're unrelated. So, what would be the probability of B given A? If you don't have to. If they're independent, this has to be the same as the regular probability of B, which is 0.1. So kind of a trick question. Because they're independent, knowing that you wore pink did not change the probability you came to school. Okay, they're independent, so knowing something already happened didn't change the probability. It's the same as the normal probability of B. Find the probability of A and not B. Okay, so if you look at your formula sheet, And tells me I'm doing what? Multiplying. So, because they're independent, I just have to do the probability of the first times the probability of the second. What is the probability of A? Okay, what's the probability of not B? You have to do 1 minus 0.1, so 0.9. Does everyone see where I got my 0.9? So if we multiply those, we get okay, find the probability of not A or B. Or means what? Add. So it's the probability of not A plus the probability of B minus the probability of both. Alright, what is the probability of not A? What's the probability of B? How do I find the probability of not A and B? Yeah, so 1 minus probability of A is 0.2, and just says you would have to multiply that by 0.1. So because it was the and, I had to multiply those two together. I hadn't calculated that piece yet. Alright, so we get 0.28. Any questions there? So, a recent survey asked families about vacation habits. Table shows where they lived and the length of their last vacation. Find each probability. So, part A. They spent 8 or more days on vacation. Alright, I did, on this one, you are given your totals. So make sure you watch that. This is the total, and this is the total. Okay? So if I said 8 or more days, how many spent 8 or more days? Out of how many total? B. They were an urban family and spent 8 or more days on vacation. So both things have to be true. So that would be just those 1 and 1, because I needed the and. Oh, I think you're on the next question. Out of everybody. So we get 0.0633. Okay. C. They were a rural family or spent 1 to 7 days. Or tells me we are doing what? Adding. Okay. So if I am going to add, how many rural people do we have? Plus, if I just said the number of rural plus the ones that went 1 to 7 days, what do I have to consider? I had 90 people that fit into both of those groups. So what do I have to do with that? Now, it's possible that maybe you didn't double count them because you just physically went through and added up numbers in the table. That's also an option. But if I'm just using those totals, I have to subtract the ones that got double counted. on vacation, given they were a suburban family. What happens when you have a given? Okay, my denominator is just that. I know they were suburban, so I'm only looking at this column. So my denominator is 95. Only looking in that column, how many spent 8 or more days? E. They were a rural family, given they spent 1 to 7 days. So now, what do I know? So I'm only looking at this first row. So my denominator is my 199. Only looking at that first row, how many were rural? How are we doing with this? Does it help going through them together? Okay. Let's look at this one. A shipment of grapefruit contains 10% pink seedless, 20% white seedless, 30% pink with seeds, and 40% white with seeds. Find the probability that a random grapefruit is seedless. How could it be seedless in this scenario? It could be pink seedless or white seedless. What's the probability it's pink seedless? 0.1. White seedless? 0.2. Can it be both? Do I have to worry about any overlap? No, not double counting anything, so just add those together. So it's 0.3. If I said pink or seedless, so which ones would I add together? The white seedless, so 0.2. What else? Pink seedless, so 0.1. What else? Pink with seeds, so 0.3. Can I do my white with seeds? No, because it doesn't fit either requirement. So we get 0.6. C. Pink, given it is seedless. If I have a given, that's my denominator. How many are seedless? 0.3. We found that in part A. Out of those 0.3, so only looking at these two seedless options, how many were pink? 0.1, so 10%. So we get 0.3 repeating. Yes.
On B, since it says or, how come you didn't have to like subtract it?
So we didn't double count because I already had them broken up. Pink seedless, white seedless, pink with seeds, so we didn't double count any. If I hadn't already broke everything into one category, then we would have to subtract.
On B, could you have just added the 0.3 for the pink with seeds?
To the
on
answer.
what we found with on A?
Yes, you could have. D. Seedless, given it is pink. So what goes on the denominator? Okay. We need all of our pink for the denominator. My pink options, I have pink seedless and I have pink with seeds. So if I put those together, it's 0.4. Out of those 0.4, how many were seedless? 0.1. So we get 0.25. Number 6. If A independent, I give you probability of A and B, the probability of A, find the probability of B. Take a second and try that one. Think about your form. If they're independent, how do we find the probability of A and B? It's just because they're independent, probability of A times probability of B. So if A and B is 0.4, probability of A is 0.8, times probability of B, what'd you get? 0.5. We just divide. When in doubt, write out your formula and see, because we have two different and formulas, one for independent and one for dependent. This one told us it was independent. Right. Number 7. Probability of A is 0.32. Probability of B is 0.11. Probability of A and B is 0.08. Are A and B independent? How could I figure that out? If they're independent, the probability of A and B has to equal probability of A times probability of B. So, let's see if that works. Probability of A, 0.32. Probability of B is 0.11. Does that equal my 0.08 for A and B? No. When I multiply those, I get so those are not equal, so what does that mean? Not independent.
What else pertinent not be the explanation?
Number 8. Probability of A is 0.4. Probability of B is 0.5. A and B are mutually exclusive. What does that mean? Right. They can't happen at the same time. Probability of A and B is 0. So how do I find the probability of A or B? Just add it. Because there's mutually exclusive, there's nothing to subtract off. So we just get 0.9. Number 9. Suppose when a job candidate interviews for a job at RJV Enterprises, the probability that he or she will want the job after the interview is 0.68. Probability that RJV wants the candidate is 0.36. Probability that A given B is 0.88. Part A, find the probability of A and B. Okay, did I tell you it's independent? No. So to do this, and means multiply. So it's probability of A times probability of B given A. But do I have B given A? No. I can flip these around. This is also the same as the probability of B times the probability of A given that B already happened. Okay, so we use whichever version we have. Because I have the information about the conditional probability A given B, I need to use this one. So the probability of B was 0.36. Probability of A given B is 0.88. And we get 0.3168. How could I find the probability of B given A now?
Put it.
If we look at this half of the formula, do I know the probability of A and B? Yeah, we just found it. It was 0.3166. The probability of A times probability of B given A. We divide. We get 0.4659. Are A and B independent? Now, if they're independent, means the probability of A would have to be the same as probability of A given B. Or probability B is the same as probability B given A. Was that the case? No. Probability of A was 0.68. That is not the same as A given B, 0.88. So no. Make sure on those questions you are justifying your answers somehow. You don't have to write me like a sentence explaining it, but you should have a justification there.
So independent means that they are equal the same.
Yes, the normal probability and the conditional are the same. All right, are they mutually exclusive? What does that mean? Right. Mutually exclusive probability of A and B happening has to be 0. So what was the probability of A and B? 3. We found out, okay, 3168. That's not 0, so they're not mutually exclusive. Let's look at this. Coin A is loaded in such a way that the probability of heads is 0.6. Coin B is a balanced coin. Both coins are tossed. Find the probability that they are both heads. How would I do that? Yeah, both heads means the first is heads and the second. So that means multiply. What's the probability that coin A is a heads? Probability of B? So if I multiply those, we get 0.3. Probability of exactly one heads. So that means I got a heads and then a tails, or tails and then heads, right? What's the probability of getting heads on the first one? And tails on the first one? Okay. Or, so plus, what's the probability of tails on the first one? Careful.
0.4.
0.4, because it's not balanced. And heads on the second one, 0.5. So we should get 0.5. Just emergency. Probability of neither were heads. If neither one is a heads, what does that tell us? Okay, so there are a couple ways you could do it. We could do 1 minus both of these, or the only way neither one would be a heads would be if we flipped 2 tails, right? So we could do 1 minus both of those, or just find the probability of tails and then tails. Probability of the first one's tails is 0.4, second one's 0.5. Alright, D. Find the probability of both showing heads given coin A shows a heads. Alright, my given is my denominator. So what's the probability that coin A is heads? 0.6. Okay. The numerator is both showing heads. What's the probability both coins are heads? Right. It was, we calculated up here, 0.3. Probably both heads is 0.3. Probably coin A is a head, 0.6. And we get 0.5. Which should seem reasonable because did flipping coin A change coin B? Now what's probably coin B? It lands heads up. 50%. Alright, this one though is different. Probably both show heads given coin B shows a head. So I already flipped my fair coin. What's probably that B was heads up? 0.5. On the top, what's probably that both were heads up? And we get 0.6. Which isn't that just the probability coin A landed heads up? Because they're independent. What you flip on one coin didn't change the other one. Alright. F. The probability of heads on coin A given exactly one head shows. So the denominator. What's the probability of exactly one heads? 0.5. We found that on part B. Okay. Probability of a heads on coin A. Coin A is my but I already know something. I already know there was only one heads, right? So this one is a little bit trickier. I can't just do the normal probability of a heads on A because I already know impossible coin flips. I know there's only one heads. Okay, so it's only those two options. What I'm looking at is the probability that coin A was heads and coin B is tails here. So what's the probability that coin A is heads? Coin A was the 60. So you're looking at that combination wrong. But coin A, the probability of heads is 60%. But that means coin B has to be tails. The probability of that is 50%. So overall this is 30%. But at the end we get 0.6 because we're still just finding the probability of a heads on coin A. What happened on coin B doesn't change it. Alright. F was tricky. How did we do with the rest of those? Okay. Do we feel better about this probability? Is it getting better? Alright. Why don't you guys take a second and try number 11. It's free. That means the first one's damage free and the second one is damage free. How many tires do I have to pick from? Okay, when I select the first one, how many of those 15 tires are damage free? 10. And I need the second one. And means multiply. If I took out one that was damage free, how many damage free tires remain? 9 out of 14. We get 0.4286. B. What's the probability exactly one is damage free? So that could mean the first one was damage free and the second one was damaged. Or it could mean the first one was damaged and the second one was damage free. What's probably the first one's damage free? Yeah, I'm just going to keep it as a fraction for a moment. And the second one being damaged. If I took out a damage free tire, how many are damaged?
5. I thought it was 14.
Because there are still all 5 damaged tires in there. Or tells me I'm going to add 1 what if the first tire I select was damaged? How many damaged tires are there? 5 out of the 15, or 1 out of 3 would be reduced. If I took out one tire, there's only 14 left, how many of those are damage free? 10, because the one I took out was damaged already. Let's make it 4, 7, 16. What's the probability that at least one is damage free? So that could mean both are damage free or one is damage free. So what should I do? You could do two options. You could do 1 minus the probability that they're both damaged, or I could add the 2 probabilities that I already have. Because here's the probability that they're both good tires, here's the probability one of them is good. So adding those together would be every combination that gave me at least one good tire. Last question for today. If I want to list the probability distribution, we haven't done this in a while, but that was just the table with our x and the probability of each. What are my possible x values? And I gave you a formula to find the probability. So if I put in a 1, 1 squared plus 5 would be 6 out of 50. If I put in a 2, 2 squared is 4, plus 5 is 9 out of 50. If I put in a 3, 9 plus 5, so 14 out of 50. If I put in a 4, 16 plus 5 would be 21 out of 50. 14. Is it a probability function? What are the 2 requirements to be a probability function? So check. Do those add up to 1? Yes. They add to 1. Every probability